applications that are basically SaaS applications. And in today's webinar, I will be talking about how we can build simple and efficient chatbots step by step. So, without any further delay, let's get started. First, let's go through the agenda to get an overall view that what we will be covering today. So, firstly, we will look at the concepts of chatbot, and after that, we have a brief overview of LLMs, and after that, we will discuss some common problems that are associated with the chatbots, and then we will look into that how crafting efficient prompts and RAG approach will deal with all these problems that are associated with the chatbots. And after that, we have the architecture of RAG approach, and then we have a demo that is basically an hands-on implementation in which we will be creating our own chatbot and we will be bringing all the theory into practice, right? So let's just start. Now, I want to start with a short story of innovation when the chatbots enter the world of customer support service. So, suppose that you own an e commerce company, and in order to respond to your customer's query efficiently, you got an idea that you should start a customer support service, right? So, basically, everything was manual first, and that was basically the pre chatbot era, right? In which everything will be manual. So, in the pre chatbot era, as I am discussing in this slide, the customers were facing some pain points. The main pain points of the customers were limited availability, as there were no service provided beyond the working hours or on holiday. The second thing was the long waiting times, as the customer have to wait on hold on call for long times, and this was causing frustration in customers. The third thing is the repetitive interactions, in which the customer have to basically repeat their issue again and again, and from one operator to another, and this was also causing frustration in customer, right? And the fourth thing was the lack of personalized service. So the lack of personalized service also give a sort of disconnected feeling with the company, and it was also making the overall image of the company negative in the mind of customer, right? So after describing all of these pain points, now the question is how can we deal with all of these pain points? So as the owner, we got an idea that what about introducing chatbots to this field. So introducing what chatbots are technically, chatbots are artificially intelligent software, and whenever the user asks a question from this chatbot, they basically comprehend that, and based on its pre-trained information, it will be responding to the user in a very human way. So this is a very cool technology, and this is helpful in various aspects of life. Like you can use chatbots for your day-to-day work and many more things, right? And now, when we start using these chatbots in our story, like integrating the chatbots in our customer support service, what happens is that this magical tool spark revolution. So, as I have discussed here, as you can see, that the chatbot started to reply in real time, and there were instantaneous responses 24/7. The second thing was availability, as they were highly available, and regardless of the time zones or holidays, they were available 24/7, right? And the third thing was offering personalized solution. So basically, the chatbots were using the customer's past history, and they were offering personalized solution to each customer, which create a sort of connection between the customer and the company, and the customer do not have to repeat their question as well, because the conversation between the customer and the bot was preserved, and that was used to respond, right? So by doing all of these advancements, the company started to make progress, and there was a high increase in customer satisfaction, and overall brand image also improved. So, by telling you all of this story, what I want you to is to realize that how impactful chatbots can be when they are integrated in an organization, or when they can be integrated in our day-to-day life. As we can see in this story, it basically resolves many of the pain points that customer were facing, right? So, this gives us an understanding about the importance that chatbot have in our life. And now we are good to dive in the technical details of everything that work behind the chatbots. Right. So moving forward, the first thing I want to discuss here is the large language model. This is the basic and the fundamental concept of chatbots. And what large language model basically are. So if you can see this picture, what happens is that when you give data like text, images, speech, structured data, and so on, and you use all of that data to train your model, the large language model can be basically used to adapt to different tasks. Like here you can see it can be adapted to the task of question and answering. It can be adapted to sentiment analysis. It can perform information extraction and so on. Right. So it is an AI algorithm that utilizes deep learning and extensive data to understand, generate, and predict the textual context. So one model can be used for many tasks, as you can see here. Now, as I'm mentioning some of these tasks here, I want to mention them in a little more detail so that we can get an overall understanding about what the large language models are capable of. So let me pull in my next slide. And yes, here, as you can see, that in the first thing I want to discuss here is the sentiment analysis. So, sentiment analysis basically means that you are instructing your model to classify the text based on the tone, right? So, if you can see here that this is a positive tone sentence, right? And the product, okay, I guess, is a neutral tone sentence, and the third sentence, your support team is used as is a negative tone sentence. So it is classifying the text based on its tone. And the second thing I want to discuss here is the summarization. So suppose that you have some research documents and you want to get only the key points from those documents. So what you can do is that you can give all of that long text document to your large language model, and it will extract the key points from it, and then you can use these key points to understand whatever was written in that long text document, right? So this will help you a lot. And by saying this, if I can go to the third task that I want to discuss, that is the task of translation. So, in translation, we mean that converting from one language to another. And if you can see, here I am converting an English language sentence into French. So, by using a trained LLM, what you can do is you can convert an English language sentence into a French language sentence, right? So, this was about translation. And the fourth thing here is the question and answering. So, generic question and answering, like when you ask some question to the large language model, it will basically, based on its pre trained information, generate a very helpful result. So, it can be used for generic question and answering as well. So, as for now, so far we have discussed the large language models and we know what they are capable of performing, right? So, by doing so, let's move on to our next slide, that is the working of chatbots. So, I want all of your attention to this flow diagram here that I have created. In this, you can see that whenever the user is asking a question, what is happening is that this question is basically transferred to this large language model. And this large language model, based on its pre trained information, will respond to the user. So this looks very simple, right? But there can be many cases in which this large language model of R can generate undesirable responses. So for describing all of those undesirable responses, let me pull in my next slide in which I am describing one of the case, and that can be that whenever the user asks a very vague question, for example, or a question that is very unrealistic. So in that case, what happen is that the large language model of ours will not be able to understand what the user is asking, and it will make up things on its own, and it will respond in an undesirable way. That is basically, it will hallucinate the things, and it will generate an undesirable response, right? So this can be one case, and the second case can be that when the required data is not available in the pre-trained data set. So if you can see here, as I have discussed already, that the large language model was trained on the large corpus of data set, right? So if what if that this data has not the information about what the user is asking? In this case, you can understand it like that, that this large corpus of data set must have a cutoff date, right? There will be some point where this data set will be ending. So what if the user asks a question about an event that was not present in this large corpus of data set? In that case also, the large language model will produce an undesirable result. And similarly, if I can say that I ask a very personalized question, for example, so what happens is that it will not have the domain specific knowledge, and as it will not have the access to my data, that's why it will result in an undesirable response in that scenario as well. So these are the two problems that I want to discuss, and all of these that I have just stated comes under the heading of limitations of large language model. The first one is hallucination, and the second one is the problem of data limitation in the model. So I'm assuming that everything is clear till now. If you have any question, please write them in the in the chat as well, right? So let's just move on to our next slides to discuss these in more detail. So I'm using some of the examples here to describe the problem of hallucination. The first one is, as you can see in this picture, that when I ask a question, when was Egypt transported to the for the second time across the Golden Gate Bridge? So you can see that this question is very unrealistic, right? So in that case, the bot is making up things on its own, as we know that none of this thing happened in October 2016, right? So it is making things on its own and it is hallucinating the responses. And in the second example, if you can see, I have asked a question that how many M's are present in the word weather. And the bot reply that the word weather contain one M, whereas we know that the word weather has no alphabet M in it, right? So in this case as well, the bot is making up things on its own and it is generating an undesirable response to me. So, till now, we have developed a good understanding about the problem of hallucination, and now we can move forward to use examples for discussing the problem of data limitation as well. So, if you can look at this first example, what I'm asking is that who is the president of US in 2024? And the bot reply that as per my last update in January 2022, I do not have access to real-time information. So this is the case that I was talking about earlier as well. The bot do not have access to this real-time data, or you can say the data after its cutoff date. Like the pre-trained data that is present in this bot is ending on year 2022. It means that all of the events that are within 2022 are present in the pre-trained data set, but the events that happen after that are not included here. That's why we got this reply, and this is also an undesirable response, right? We do not want it here. Now, the second example can be that where what are the core values of my company shop is. So when I ask this question, as you can see that I'm asking a very specific question that is related to my company, like it's a very personalized question. So in that case as well, the bot reply, I do not have access to specific information about your company unless you provide it to me. It means that it do not have access to my data, and hence it is unable to produce a good result or a desirable result. And we can see here that it has just give me an update that it do not have access to my data. So these are the two examples that describes the problem of data limitation to us. And now, as we have a good understanding about the two common problems of large language model, first was the hallucination and second was the data limitation. Now the question arises is that how can we basically overcome these limitations of large language model, right? So far we have covered the two problems, and now moving on to the solution parts to resolve these problems. The first solution that I want to discuss is efficient prompting. So here I'm using a very simple example to describe that, and efficient prompting is basically related to the whole domain of prompt engineering, and I'm not going into much detail about it, but I have some points here and that must be included in the prompt to make it effective. So if I can discuss that, the first one is to give a specific role to the chatbot. So if you can see in my example here, in the first line, I have written that you are an intelligent assistant that count the number of times a specific alphabet appear in the given word asked by a user. So this is how you define a role to a chatbot. That will basically help the chatbot to understand what task it has to perform or what role it has in this scenario. And after that, the second thing you can do is writing clear and specific instructions. So here I'm writing these two instructions, and written it in bullet points, and you can see the line that follow each of the instruction given below. This line is included to create an emphasis on these 2 points, right? So writing clear and specific instruction and defining role to the chatbot. The third thing can be to give examples, and by this I mean giving more context to the language model by describing that what the user can ask and what the bot should reply. So I have written down two examples here that should be used in this scenario of mine. And after that, what I have done is I have asked a very clear and specific question. So this is also one of the things that you should be clear and precise in asking the question to a large language model so that it do not make up things on its own, right? So as you can see in this question, I am asking count the number of times O appear in the word weather, and it reply count is equals to 0. But this question is pretty much similar to what we have seen in the problems, right? And there it was not responding correctly. So it means that by giving all of this context that I have written here, the bot start to reply in a good way. So this basically tells us the importance of prompts, and we should include these points that I have written here to make effective prompts. So this was the first technique, and now moving on to my second technique, that is the retrieval augmented generation. So what we do in this technique is we enhance the output of large language model by giving them an additional information using this external knowledge base. This external knowledge base will have all of our data that we want our model to know, right? So all of the information of our choice will be loaded in this external knowledge base, and then we will utilize that to produce good results from the large language model. If you can see this flow diagram, you can remember that this is pretty much similar to what we have seen in the working of chatbots, right? So this is similar, but the thing I've added here is this external knowledge base, and the flow now is like that. Whenever the user is asking a query, that query will not be directly transferred to this large language model. That query will be used to first search in this external knowledge base, and after that, what we do is when we search for some relevant documents in this external knowledge base of ours, we will get some relevant documents and we will append them to our query, and we will send that to our large language model, right? So what is happening here, that we are giving more context to our large language model by adding some relevant information as well. We are not passing this query directly to this large language model of ours. So this will, if you can understand this, this will help us in removing the problem of data limitation to a great extent, right? As we were seeing previously, that the model do not have knowledge about the data related to some recent events or about our personal information, right? Like the legal documents or anything like that. So now in this case, as we are uploading all the information that we want our model to know, that in that case the model will have the knowledge and it will reply to the user in a great manner, right? So by saying this, now there can be two questions. First one can be that how are we making this external knowledge base, right? And the second question can be that even if we make this external knowledge base, how can we integrate that in this whole flow of ours? So for that, we have the RAG architecture. So, moving on to the RAG architecture, the first step I want to discuss here is to create this external knowledge base in which we will be uploading our information. For that, we have to follow some steps here. As you can see that there are four steps. So the first one here is loading of data. So by loading, I mean that whatever data you want your model to know, that can be in form of PDF or that can be in URLs or anything else, right? Textual data can also be there. So what you want to do is you want to extract all of the textual information from that, and by doing so you make a big text block, and by making this text block, what you do is in the second step you basically break that text block into smaller chunks. So what we have done, we have extracted some of the textual information from the text block, and after that we have made chunks out of it, right? So by splitting, if someone can ask that why we are doing this splitting thing, right? So if I can move backward and show you this again, that the reason for splitting is whenever the user is asking a question, what we want to do is we want to add some of the relevant documents to the query, right? We do not want this whole external knowledge. We want some of the documents that are related to the user query to be appended with the query, and we are passing that as prompt to our large language model. So, in this case, the splitting will help us as it will chunk out our documents. And the second reason for chunking is that, or for breaking the text into small documents, is that our prompt will have a token size limit. And we do not want to exceed it. That's why we have to put only the relevant chunks with our query and pass that to our large language model, right? So this was the reason that we do splitting. And after that, when we are done with our splitting part, we embed the documents. So by embedding, I means converting the text information into vectors. Why I'm doing so? It is because of the reason that the machines cannot understand alphabets, right? So it understand numbers, and we are basically generating the meaning of the alphabets in form of numbers, so that a machine can understand that in a great way. By saying this, if I can move backward again and explain that using my diagram. So, as I have discussed, the user is asking a question and we want to extract some relevant documents from it, right? But what we want here to, what we basically want here is that we do not want exact keyword matching of this query with our external knowledge base information. We want to infer the meaning of this query, and based on the inferred meaning of this query, we want to retrieve the relevant document. So this means that we want to semantically look for the relevant piece of information, and we want to extract that. For that, we have to perform vector search, and for performing the vector search, we have to convert the strings into vectors. And by doing so, we are good to move forward to our next step, that is storing the documents. And in that, we are basically storing our chunks that is in the form of vectors into a vector store. So by performing all of these four steps, we have created an external knowledge base so far. Now we are good to move towards our next step, that can be the retrieval and generation part. So in the retrieval and generation part, what happens is that we whenever the user is asking a query, this is pretty much similar to what we have discussed so far, right? So whenever the user is asking a query, what I'm doing is I am joining this query with these relevant textual documents that I'm retrieving, and these are basically the relevant documents that are based on this user's query inferred meaning, right? So I am retrieving those documents, I am appending all of these things in the prompt, and I'm passing that to our large language model. So when we do that, what happens is that the large language model is able to produce more efficient results. So by saying all of this, till now we have covered the two techniques to make the large language models respond in a better way. The first technique was creating efficient prompting, and the second technique is the RAG approach, right? So now as we are done with our technicalities of making good responses, we can move forward to this part, that is the essential elements for our implementation part, right? So I will be quickly going through this, and this will be helpful in our implementation part that we will be covering soon. So the first thing here is the large language models. So as I have discussed, what we want for making a chatbot are the large language model. Then we apply some prompt engineering techniques to it, and there will be a vector store to perform RAG, right? So in order to connect all of these things and to make everything join, we need a framework. This framework will join everything, and it will make an AI application for us. So by saying so, the framework that we are using here is the LangChain framework. LangChain is an open source framework designed to simplify the creation of applications that use large language model. The cool thing about LangChain is that it is an open source framework with a lot of built-in methods. Like you can see in this picture also, all of the technique that we have covered so far can be easily utilized using these pre-built methods. Like it has method for creating models, it has method for creating prompts, for retrieving the documents, loading the documents, using different type of vector store and so on. So this is a very cool framework that will help us to design our AI application in a very simple manner. So as we have discussed LangChain as well, and we are all good with the technicalities that we have discussed to make efficient bots, now we can move forward and put everything that we just see in the theory part into practice, right? For that, we have some prerequisites of the code as well. So if you can see here, we need access to OpenAI Azure service. So Azure OpenAI service is something that I'm utilizing here, but if you do not have access to that right now, you do not have to worry, as I will be sharing my code with you, and you will have the video with you, so you can always look into that. And the second thing here I want to discuss is you can also use the trial version that Azure provide, that will be enough for experimentation as well, right? And the second thing here is that I'm using Jupyter Notebook for execution of my code. So let's jump on to the code, and let me share my screen again for that. All right, is my screen visible to everyone? Perfect. So let me start that. So here in this case, what I am doing is that, yes, so here in this case, what I'm doing is I am building a customer support service chatbot for a company named ShopEase. So this is an hypothetical company that I am using here, and if I can show you my text file as well. Let's just zoom it a bit. So yeah, this is my text file, and all of this data that you are seeing right now is the data that I have created. This is a dummy data basically, and as you can see, I'm the founder of the company, and we have about us page as well, core values of the shop, vision, products available at the shop ease, and we you can see that there are electronic goods, fashion goods, and so on, right? So this whole data is basically the data that I have created. This is a dummy data, and that is for an hypothetical company naming Shop Ease. So if I can go back to my notebook, what you can see here is that firstly, we will be looking at all of the cells that are present in the notebook, and we will see that how each of the line is working. So for that, if you can see, the first thing is the installation part. So installation of necessary libraries will be done firstly, and for that we use pip install command of Python, and I can run this, and let's see. Yes, so the next thing here is creating an external knowledge base. So by meaning of external knowledge base, as discussed in our theory part as well, what we want to do is that we want to upload the information that we have, the personal information, so that it can be accessible to the large language model, right? So for that case, we have to make an external knowledge base. And for that case, as we have discussed in these slides as well, we have to follow few of these steps for making an external knowledge base, right? So for that, if I move a little bit down, you can see that the first step is to load the document. I have shown you my document, that is this text file name demo data shop.txt, as it said text file. So what I'm doing here is that I am first loading its path in a variable name file path, and after that I am using this text loader component of LangChain document loaders. And in this text loader document, I am passing this file path that I have given. And when you do that, what happens is that you have created an instance of text loader, and you have to basically use this load method of the text loader, right? So when you use this dot load method, all of the textual information that I was just showing you and that was present in my text file, right, that will be extracted and it will be assigned to the variable document here. So let me quickly run these cells, and if I can show you the document, this is how the document look. It look pretty clustered here, but if you can see that this is a document type object, and in that we have the page content attribute, and in that we have all of our textual information, right? So I can show you the only the text as well. For that, what we have to do is, as you can see that this is a list, so we will write this, and in it basically using the first element of the list and using the page content attribute. Let me print that for you. Yes. So this is pretty much similar to what we were seeing in the text file, right? It has about us page, it has core values, it has vision, and the data goes on. So all of the textual information from my text file has been loaded to the document variable till now. So as now we have a big text block with us, the second step was to split that big block of text into chunks, right? For that, I'm using a recursive character text splitter. Now, the cool thing about recursive character text splitter is that it will be splitting the big text block again and again until it reaches the fixed chunk size that we define. Like here, you can see that I am defining the chunk size as 2000. It means that the block of text will be splitted again and again until the chunk is within the range of 2000. Now, the second thing here is the overlap. As you can see here that I have written overlap is equals to 800. So overlap means that it is the count of characters that you want to be overridden, or you can say overlap in your adjacent chunks. Like if you can say you have two chunks, right? The first chunk, the basically the last line of the first chunk would be the first line of the second chunk. So this is how you will be overlapping everything together, and this is basically to maintain continuity and to maintain the information and relation between the chunks, right? So for that we are doing overlapping. And the third thing here is the length function. This is to define how the length of the chunk is calculated, and here we are using this length function of Python. Let me run this cell for you. And now, if you can see in this line here, what we are doing is after initializing this recursive character text splitter, we are using split document method of the LangChain, of course, and we are passing document variable that have all the text block that we have just seen earlier in our code to this split document method, and it will make chunks for us. So if I can run this line, and let me quickly show you the chunks as well. Yes, so these are the chunks. If you can, this is a bit clustered, but if you can bear with me, this is the first chunk, and if I can scroll a bit, this is basically the second chunk, and the list goes on. So this looks a bit clustered, but let's just print the length of the chunks as well so we can see that how many chunks have been created from our large text document that was in this text file, right? So this was my text file, and now I have created chunks from it. And if I show you guys the length of chunks, that is 20. So it means that the large text document is converted into 20 small pieces, right? So now as we have our chunks ready, what we have to do is we have to embed those chunks and store them in a vector store, right? So for that purpose, for embedding, I'm using the text embedding model. And as I have said in my prerequisite as well, I'm using Azure OpenAI service, right? So I'm using the text model of OpenAI, and if you can see in this line, I am importing the Azure OpenAI embedding component from LangChain OpenAI. And if I scroll a bit, you can see that I am initializing this Azure OpenAI embedding in this way. So if you can see here that I am passing the OpenAI API key, embedding model, base URL, and so on. So these things are should be passed in a secure way. And the best practice is to use a .env file for that. So what we do is whenever we create an OpenAI service on Azure portal, we will be given all of these things. So we put all of that in a .env file, and we use this load.env method to load everything, load every environment variable up, and then we use those variables in our instantiation so that everything can be retrieved securely. Some cost is associated with it, so that's why we are using this best practice here. And let me run these cells as well. So far we have our chunks with us. We have created our embedding model as well that will be converting the textual information into vectors, right? So if I can show you how this will happen, suppose that this is a string. I am making a string and I can assign a variable text to it. Now what I can do is I can use this embeddings model that I was showing you that has the capability of converting string into vectors, right? So I can use this model and I can use its function name embed query, and I can pass this text variable of mine to it. And if I print that, you can see that this text is basically converted into vector format, and it means that the information present in this text is demonstrated to my language model in the format of vectors. So this is how your language model will be working. And now as we have our large language model with us, sorry, the embedding model with us, what we want to do is we have to store everything in the vector store, right? For that I'm using the Chroma DB. You can use other vector stores as well. So I am importing Chroma here. And in Chroma, there is basically in LangChain, there is a method named from document. And what you have to do is you have to pass the chunks that you have, and you have to pass your embeddings. And by passing these two parameters, it will make the vector store for you. So that's why LangChain is a pretty simple and straightforward framework. It has many pre-built methods in it. So now we have our vector store with us, right? So the second step, or we can say the last step in it, is to make this vector store as a retriever object. So the purpose of making a vector store as retriever is that we want to retrieve some relevant documents on the go, right? Whenever the user will ask a question, we want to retrieve some relevant documents out of this vector store, and we want to use them in our uh, result generation, right? So for that, we have to make the vector store as retriever. And in that, what you have to do is what I am doing basically is that I am passing this search argument as well. So by passing this argument, what happens is it will retrieve only four relevant splits, as I want only four relevant chunks because my text document that I was just showing you is very small. So that's why I'm retrieving only four documents from here. And now we have our knowledge base ready, and we can move forward to our next step as we have discussed in the theory as well, right? Our next step was to retrieve and generate. So in the generation part, basically when the LLM generate responses, we are using Azure OpenAI model again, and here I'm using OpenAI 3.5 Turbo. And if you can see here, if I scroll a bit down, I am again importing an Azure Chat OpenAI model from LangChain .chat model, and it is also pretty much similar. Its instantiation is basically pretty much similar to what we have seen in the embedding model, right? So we have to pass all of these value, and these values will come from the .env file. And the new thing here will be this temperature. So what I mean by this temperature is that uh, temperature defines that how creative you want your model to be, right? Like if you want to build a chatbot, you can say, for blog writing or for essay writing, you want your model to be very creative. But in our case, as we want to make a chatbot for a customer support service, and we want our model to be very specific and very strict, that should stick to our instructions, right? So in that case, we have to make the model less random, or we can say less creative, and that's why we place a smaller value of temperature here. I am putting 0 0.2 here so that my model can stick to my instructions, and we can ignore this warning as this is for only the updated, for using the updated version actually. And now, as we have our large language model with us, we have our external knowledge base with us. So the next step can be to create a nice and efficient prompt, right? As we have discussed in the theory part as well, that what we will do in that is we will firstly specify the role in the prompt, and then we will specify some instructions. So here, if you can see in the string that I have created, name prompt, I am writing that you are a dedicated customer support representative for a company named Shopee, a leading online retailer, and I've also defined the goal here. And after that, what I'm doing is I am mentioning some of the instructions that I want my model to follow in this scenario. So for that, I've listed that answer should be always generated from the sources listed below. Your response should be complete and concise, and do not list the sources in the answer. So these are the instructions that I want my model to follow, and this is the role. Now, prompting is a very fundamental thing, and this basically make a very great impact on the large language model's response. So you have to be very careful when crafting your prompt, right? So if I can go a little bit down, you can see here that under the sources heading and the question heading, we have two variables as well. So the value of these variable will be replaced by basically the value will be pasted here and in the query on the go, right? Like when the user will be asking the question, the value will be pasted here, and the context that we will be retrieving will be pasted here. And in our case, that will be four relevant documents, right? So all of that thing will be placed on the go. And as we have made our string for our prompt, now what we have to do is we have to convert this prompt into we have to convert this string basically into a prompt. So for that, I'm using prompt template and I will pass my prompt to it. This is the variable that has my instruction, right? So I'm passing that to it. And after that, we will be declaring the input variables that were context in query in our case, and it will make the prompt for us. And after that, what we have to do is we have to make the chain like by this is a simple chain, and I'm using only the LangChain expression language for it. And what I'm doing here is that I am the prompt that I have created, the customized prompt. I will put that here, and I will use this vertical line, and I will put my large language model that I've just instantiated above in my code. So after putting all of that, when I run this cell, our chain will be created and we are good to go. And let me just use this example here that for understanding, for making you all to understand the flow that will actually will be followed when the user will be asking a question, right? So for that, if you can see here, firstly, I am asking the question that what is the vision of the company? As again, I am repeating that I have made a chatbot customer support service, chatbot for the customer support service, and that is for a company named Shopee. So what I'm doing here is I'm asking a question about the company, that what is the vision of the company. And if you can see here that this question is pretty vague, but now as our model will have context about our company, as I am making sure that in my prompt I'm declaring that in a very clear way. So now the model will not misunderstand things and it will generate good responses. That's why we have done all of that prompting thing, right? So when we have this query, the step that we will follow is that we will pass this query to get relevant documents first. That is by passing that is by using this get relevant document method on the retriever object. And when we have our four relevant documents, we will pass all those relevant documents along with the user's query to our prompt, and we will invoke our chain. So this will be the flow. And if I can run these cells, and this line of code is basically to show you all the relevant documents that have been retrieved when the query is asked about the vision of the company. So if you can see here that in my first chunk, we have some information related to the vision of the company, right? You can see this heading vision, and it has information related to the vision, and this is basically the chunk from the source that I have given and what I have shown you previously, right? And the first count can be, this is I am starting the count from zero, so you can say that this is the second source, and in that we have the content that is also related to vision, like it is talking about innovation, teamwork, sustainability, somewhat related to vision, right? And in the third chunk of ours, we have information related to vision. As you can see, in pursuit of our vision, we aim to, and all of these points are given. So this was our third chunk, and our fourth chunk is this, in which it is talking again about vision. As we work towards achieving our vision, we need to join, and the information goes on, right? So these four chunks are basically related to vision that have been retrieved from our document, and we are not pasting our whole document into our prompt, but rather we are using these four chunks of our to paste them in the prompt on the go, right? This is what we have discussed so far as well, and we will pass all of that. And here, if I can run this cell, our result have been generated, and we can actually see the result as well. So this is the result that have been generated, right? It has this content field, and in the content field we have all of our result. And if I can read that out, the bot said that the vision of Shopee is to become the preferred destination for online shopping, renowned for exceptional customer service, and the information goes on. So this lines basically are retrieved as I've created the dummy data, so I know about the document. And if you can see here that this line was present in my document, like if you can see here, it says at Shop Ease, our vision is clear. We aspire to become the preferred destination for online shopping, renowned for exceptional customer service, and the information goes on. So this means that the bot has replied to me from the document that I have given, and in the prompt as well, I have written that answer only from the sources, so it is also following those instructions. So this is how you are making a chatbot that is purely related to your document, and it is behaving in a very efficient way, following all your instructions, right? So this was all about the technical aspects of what we have seen in the theory part as well, and we have covered all of the technical aspects like creating efficient prompts, like using the RAG approach, and so on. So every technical aspects have been covered, and now I want to quickly discuss the user interface as well. So for user interface, I'm using the Gradio application. Gradio is basically a open source Python package that allow you to quickly build a demo. So this is a very simple or and a vast, of course, vast documentation, and it has many boiler codes for its components as well, right? So in Gradio, I am using its chatbot component, and what I have done here is, this is basically the boiler code that Gradio gives, and I am just tweaking that a bit by adding markdowns here, by adding some avatars, and changing some of the scales of the text box and so on. So I've made some changes, and after that the main thing here will be this respond function. So if you can see here, message dot submit means whenever the user will be clicking on the submit button, or whenever the user is hitting the enter button. So in both of the cases, what happens is that this respond function will be called. And if I can go above and show you the respond function, this respond function is also given in the boiler code, and what happens here is that when the user's question and the chat history is passed as parameters in this respond function, and then in the bot message I am using my own functions pipeline to respond, to make the response, right? So why I'm doing this, this is because of the fact that we want to use all of our technicalities, like we want to use our rack pipeline, we want to use our customized prompt, right? So for that I have made my own function, and I'm passing user's query to it, and all of the reply that the bot will give to me will be passed to this bot message. In that way, every time this respond message will be called, like by clicking on the submit button, every time my pipeline will be used to generate result, right? So after getting this bot message, we will append that in the chat history and we will return that. And if you can see here, this is the function that I have created, and if you look closely to it, it is pretty much similar to what we have discussed so far, that whenever the user is asking a question, this question is basically used to retrieve some relevant document using retriever dot get relevant documents method. And after retrieving the relevant documents, in our case that will be four chunks, right? So after retrieving that, what we are doing is we are passing those relevant documents along with the user's query in our prompt. And then when I use this chain.invoke method, what happens is that my prompt will be modified, and instead of this query variable and the context variable in my prompt, the values from this question and this relevant document will be pasted there, and that modified prompt will be sent to my large language model, right? So the result will be like this, as I have shown you here as well, right? Manually I have shown you that as well, that it will look like this, like in the content field we will have the result, right? So what we can do is we only want to use this string, so for that we can use result dot content and we can use that as our response. So I am doing that here and I'm returning the response. So let me quickly run these all, and if I can show you, yes, so let's go to our interface. This is the interface that I have created from using the Gradio boiler code. And if I can show you, if I write that, hi, need some help here. And the bot replied, of course, I'm here to help and what I can assist with you. And you can, let's just ask a very specific question that is related to my document. So if I can ask, let's say about the products of the company. So if I ask, what products do you offer? Again, if you can see, this is a very vague question, right? The model will not know what you means, but in the prompt, I have specified that the bot is related to the customer support service for the company shop east. So it has some context and it must reply in a good manner. Let's wait for a minute. Yes. So you can see that the bot has given me a pretty good result describing all of the products that they offer, and it has not misunderstood things because I have written everything in the prompt and I'm giving some relevant documents to it, right? And let's ask another question, that what is the return exchange policy here? And the bot replied that our return exchange policy at ShopEase allows customer to return products within 2 days of receipt, and the information goes on. So this is also a pretty good response purely from the documents that I have given, and it is not hallucinating, not giving me errors like for the data limitation, because I've given everything to it, right? So this is how you make a user interface for the chatbot, and if you can see closely that only the user's question and the bot's reply is shown on the screen, right? Every technicality that we have used, like RAG approach or crafting efficient prompt, everything is hidden behind the scenes, right? So this is why you create a UI, so that the user can only see the easy part, and all the technicalities can be abstracted behind this interface, and you can use that to make your chatbots respond in an efficient way. Right, so this brings us to the end of the coding part of building simple and efficient chatbots. And now I am open for my question answer session. So let me pull that screen up. Yes, so let's just go through some of the questions. Someone is asking about the GitHub link. Please give me the GitHub link. Yeah, for sure, I can give you that. Just give me a moment. This is the GitHub link, and let me just maximize my screen. Okay, let's go through the questions. Hmm, chatbot, very which Gemini video? Um, should not we use fine tune the pre-trained LLM on dataset related? Yeah, you can also fine tune. So someone has asked that if we can fine tune the pre-trained model on the dataset that is related to us, right? The specific data. So you can fine tune that as well, but it require, you can say, more knowledge, and it requires more cost as well with it. As in my case, what I'm doing is I'm making the model learning the things on the go, right? I am not changing the model. I am basically using utilizing the prompt for context learning, that in technical way you can say that. So we can also do fine tuning, but it is a very comprehensive thing and a hard thing also, and you are also not sure about the result, but you can do that as well. um, can you ask LLM to do predictive analysis? Yes, it can do predictive analysis, but again, as I am saying that you have to craft the prompt like that. Like you have to tell your model that what you want it to perform, and uh, for that purpose, what you can do is you can in the prompt you can specify the role, like you are specifically for this purpose, like for predictive analysis and so on. Mm, what products or platforms are most commonly used for RAG creation? Okay, so products, you can basically, I'm utilizing frameworks for performing this RAG concept, like, right? So the RAG is a concept, and you have to use some frameworks, like you can use LangChain or you can use Llama Index to perform RAG, so that you can basically perform it in a very easy way, you can say, in a very efficient way. And is there is a RAG API for Gemini? Um, yeah, you can follow my steps and you can see how Gemini can work for RAG. I was basically telling you the concept that how can you use RAG, and you can use any of the large language model and see what happens if you use RAG to it. Like it is a concept, and you can apply it to any model, and you can use any of the vector stores as well. So if that answers your question. How to know the chunk size so we can make sure the whole answer is in one chunk? Let me give a moment to understand this question. How to know the chunk size? Mm. Okay, so someone has asked how to know the chunk size so we can make sure the whole answer is within one chunk, or is it able to use more than one chunk? and get one answer. Yes, so you can use more than one chunk, as in my tutorial that I was showing to you. I was retrieving four relevant chunks, right? So you can use more than one chunks to get one answer, basically, that I was doing in my case. And you can there are many methods to optimize the chunk size as well. Like there are many methods to in my case, I'm using the recursive character tag splitter, right? You can use semantic splitters as well. So there are multiple things to optimize the chunk size as well. Like based on your information, it will chunk your document. So that is also the thing. Usual size of the split is the usual side of the split is it depends upon your document. Like I have shown you my document, it was a pretty small document. So based on that, I was specifying the characters that were 2000 in my case, right? So I want only 2000 characters in one chunk. That is why I have used that for my small documents. Mm, so are we using the LLMs itself in the QA system to get the embedding of the query? No, so we are using the LLM itself in the QA system to get no, the embeddings are created from the text model that I was showing to you. I was using an OpenAI text model, and the LLM that I was using was OpenAI 3.5 Turbo that was used for the Q&A, right? So these were two separate models that I was using that both were of Azure OpenAI, as I have discussed so far as well. Is there any risk to load your personal data to the large language model? Can that information be? No. Someone has asked, Ami Singh has asked that is there any risk to load our personal data to large language models? Can that information be compromised by the outside source? So this is the reason that we are performing RAG, that we are not making our data public. We are making our own external knowledge base, and that we can secure that in many ways. If you use Azure services, that can be secured in multiple of ways, and you are not making your data public. So you can load your personal data as well. Mm, do the chunk boundaries form since it break the chunks on complete sentence of the text input? So someone has asked that do the chunk boundaries form on complete sentence of the text input? Um, uh, I'm not understanding this question perfectly, but I think that you mean about the characters it is using for splitting the document. So in that case, I was using recursive character text splitter, and I have, if I can go back to my slide. Mm, in the recursive characters text splitter, what you do is you use, where is the character text splitter? Yes. So these were the characters that it was using previously uh to basically make the chunks, like the line changing characters. And as I was discussing that instead of line changing characters, you can also define your characters on your own, and you can also use other splitters as well. LangChain have a very vast library on text splitters, so you can go through that as well. Very Um, what is the length of the document list? So by document list, I think that you mean the document I was uploading. I was uploading only one document, and that was a pretty small document, and I have basically converted that into smaller chunks that were of 2000 characters, right? What is the scalability of chroma vector stores? So yes, so for the scalability thing, you can always go to its official documentation as well. There are many things to describe that, like we have many parameters to see that it can be scalable or not. Is it in memory or not? So there are multiple of things, and you can basically go to the vector stores documentation every time to see that. GitHub repo, made presentation. I think that I have, if I have not answered someone question, so uh, you can always reach out to me on my LinkedIn profile as well if I am skipping someone's question. So you do not have to worry in that case as well. I will reply there as well. Where is the OpenAI text model? Someone named Deep has asked that. So the OpenAI text model is basically present on my Azure portal, and when you log into Azure portal, you can see that you can create many of the services, and in that I am using the OpenAI service there, and in that I'm creating the two models that one was the text model and the other was for the Q&A, that was GPT 3.5 Turbo. Is there is there someone has asked that is there a free service available in place of Azure OpenAI service? So yeah, there are many. Basically, there are many open source models that you can use for using this RAG approach, and everything that I have covered. There are many OpenAI models for that as well, and I've also made a blog on llama indexing, and there are multiple videos as well at Data Science Dojo's page. You can go through them as well for using open source models. So if that answer your question, yes, free services are available in place of Azure OpenAI. When you say chunk, you meant a character. No, by chunk I mean the pieces of information that I have. So that was the chunk. Like if you can see here, where I have printed the chunk, I can quickly show you that. I think in the last. Yes. So this is basically one chunk. This is not one character, right? This is one chunk, and this is the second chunk, and so on. What is There are many, someone has asked about my blog, so I can share the link here as well. And there are many blogs available at the Data Science Dojo's page as well. So you can go through them uh, every time. If I can quickly share that with you. Okay, I think we are pretty much up the time. I am just going through few more questions and then we will wrap up. So, um, what Ami Singh has asked that for a developer who is getting into Gen AI LLM development or prompt engineering, what learning paths do you recommend? So for that, you can always go through the boot camps that Data Science Dojo provide. They are very comprehensive, actually, and you get a very good grasp on the fundamental concept from that, and also on the advanced topic. So you can go to that as well, and you can also, this was basically the my webinar was basically telling the most fundamental things. So you are good to go and you can explore prompt engineering more and rag more in more detail. Like